Welcome to week 16 of science videos. Today we are talking about gravity. Gravity is the pull of an object toward the center of another object. We know that the earth pulls us and everything on the surface toward its core or toward its center. Today we're doing two experiments that talk about two different ideas of how number one, surface tension and air resistance, and then number two, rolling speed can affect the speed or how quickly something is pulled toward the center of the earth or toward gravity. So the first experiment, breakthrough, is using two pieces of white paper, which you have in your crates, and pencil, and instead of using a compass to make a perfect circle, we're going to just trace the outside of this bowl. It makes a 7.5-inch diameter circle, which works perfect. You're going to trace your circle, cut out your two pieces of paper so they are exactly the same, and you will end up with two circles that look like this. They are exactly the same diameter, cut at the same time, out of the same kind of paper. One circle you're going to leave the same. The second one you're going to cut from the edge right to the center of the paper. After you have that, you're going to fold this one into the shape of a cone. So it looks similar to this. You just fold it over. Then you're going to have two pieces of tape that are equal, the same, about 1 inch length. You're going to put one to hold your cone shape. And then your other piece of tape, actually I already have on here, and the center of your flat circle. So you can ask your kids. We know both of these circles or shapes started out as the same diameter and size, and again made out of the same kind of paper, and we now have the same weight because they have the pretty much exact size piece of tape on there. So we're going to drop these. Which one do you think will hit the ground faster and why? Alright, so when we drop them, the cone is a lot faster, as you can see. And why is that? Well, one of the things that affect the pull of gravity is air resistance. There is atmosphere, air molecules all around us, and they create a resistance. So as the paper falls down, there's air molecules pushing back up or creating a resistance. It's kind of like we learned about water tension a couple weeks ago and how they create like a skin. You have to break that tension. Same thing's happening here. You have to break the tension or the hold of the air molecules. Shape makes a difference. A bigger flat circle was created bigger air resistance or pressure against the paper. This, being in its cone shape, is a more aerodynamic shape, meaning it can cut through the air molecules a lot easier and then hits it faster. It is not as big, has less air resistance, and so wins the race. Talk about then how engineers use that aspect of aerodynamics to create planes, rockets, vehicles, to make things go faster through the air molecules. Our second experiment is called Shape Up, and in this experiment we're going to have you're going to have two books. They look like this. They'll be this shape. You have two books of equal length. You're going to prop them under the legs of a table in one of the tables in your classroom. So just under one end, both legs, so that your table's at a little angle. Once it's at a little angle, again, we're going to talk about gravity. Again, what did we say gravity is? It's the pull of something toward the center of something else. And so we know things are pulled toward the earth from the center, or pulled toward the center of the earth by gravity. So when things fall to the ground, they're simply going straight down. It's a dropping speed or a drop to gravity. When things roll, it becomes a little different. So now we still know that gravity is going to pull our objects down toward the slant. But how can the shape of something affect how quickly it rolls. We saw in the paper the air resistance and how shape affects its drop speed. Well, how can shape or size affect its rolling speed? And so to do this, I'm going to have a helper.
Yay!
Okay, put it at the line. So you're going to have a roll of masking tape, a golf ball, I got it, a little golf ball, and a marble. And we want to know, which one do you think is going to get to the other side of the table the fastest? Get their hypotheses and talk about why they think that. Okay, on the count of 3, we're going to let go of our objects. 1, 2, 3.
Oh, that one went off the side. Oh, no, look. Oh, that one went off.
Okay. So, ours went a little haywire, yours might too. Just start again and try again. Any way you do it, the marble always wins. And why is that? Well, when objects are pulled toward gravity, and the rolling speed, what is different is the object itself actually has to work to get rolling. And so it is dependent on its own center of gravity. The center of gravity is where an object balances. So everything has a center of gravity or it falls over. Buildings have a center of gravity that holds them up. This ball has a center of gravity. The closer the outside is to the center of gravity, the less work it has to do to get rolling. And so this marble is firm and compact. It is full of glass and material. So its center of gravity is much more condensed and smaller than this hollow golf ball or our roll of masking tape or painter's tape. And so the bigger the center of gravity, the more work it has to do. And again, that slows it down in its rolling speed. So you can do this, have kids each come up, 3 of them at a time, get to take a turn in racing it, put them in a different order. You can even prop your table up higher if you want, just to play around and see if that affects it at all. One cool thing I thought was neat, if you wanted to throw in there at the end, is again, dropping speed is different than rolling speed. And so even though the marble was a winner in rolling speed, if we drop them, they drop at the exact same speed. They both hit the ground at the same time, and that is because gravity is pulling on each of those objects equally. They all are round, so they have a similar shape to go through the air molecules and air resistance. So that's kind of cool. You can talk about the difference there, about the dropping, the pull of gravity there versus rolling and them having to work. And that depends on their own center of gravity. Refer to your Van Cleves as well as our Nicole Liam papers and have fun with it. Thanks.